Hi, everybody. Welcome back. Going live for the first time, so probably nobody's watching right now. If you are, hi. But otherwise, mostly I'm doing this because it's a bit more convenient than recording it and uploading it later. So I want to go over a couple problems from the test we had on Friday, give you some of the breakdown of the numbers there. And then so tomorrow, if you want to stop by, or I guess you'll probably watch this on Monday. So on Monday or Wednesday, if you want to stop by my office hours and ask about some of these, I'll give you the opportunity to do so. Also talk a little bit about how we're going to be adjusting things starting next week for the new quarter. All right, so first off, let me give you the number breakdown from the test, just like I would in class. The range, so this was a test out of 60 points, not out of 100 like we normally do. Wanted to make it a bit shorter for you guys, but the range was very large, over 30 out of 60 points. I won't tell you exactly what it was, but it was pretty large. So we had a pretty large gap between the top score and the bottom score. On the other hand, the other numbers look pretty good. The mean, the average score was 43 out of 60. Our median, the score that half of you got above and half below, was 50 out of 60. And the mode, the most common score was actually an A for once. So I was pretty pleased to see that. Hopefully this is a sign of good things to come, and you guys can keep up the hard work. So a couple of problems from this test I wanted to go over. Again, if there are other ones you want to go over, just stop by my office hours, and I'll be glad to go through them with you. So the first one is number 9, a type of problem that we've been having issues with throughout the year because it involves fractions, and everybody loves fractions. The only thing worse than fractions are decimals. Yeah, sorry. It just is what it is. So don't let the fact that it has fractions scare you. We're still going to approach this like any other algebraic equation. So we're going to need to isolate the variable, get that on one side, get our constants on the other side, and then get rid of any coefficients. So that's exactly what we're going to do here. Now, the way the equation is currently set up, you have everything mixed together on the left side of the equation, and you have 0 on the right. Am I a mirror image here? I think I might be. Well, maybe we'll have to deal with that later. So it's 1/3 plus 5 1/3 k plus 3 and 2. Sorry, 1/3, 5 1/3 k plus 3 and 2/9. So you'll notice both that we have two constants here, and also the constants and the variable are on the same side of the equation. So the first thing we always want to do is simplify, combine anything that we can. The k, there's only that one variable there, so we can't combine it with anything, but we can combine these two constants, the 1/3 and the 3 and 2/9. Now, normally, when we add fractions, we have to make sure that they have the same number on the bottom, the same denominator. Here, since 3 and 9 are pretty easy to work with, we can mostly do it in our heads. So 1/3 is 3/9. So we're going to take 3/9 and add it to 3 and 2/9, and we'll get 3. Now that we've simplified it, we can move our constants over to one side and the variables on the other. Variables are already all on the left, so let's move the constants to the right. We'll do that by subtracting 3 and 5/9 from both sides. So that cancels out over here. We subtract 3 and 5/9 over here. 0 minus 3 and 5/9 gives us negative 3 and 5/9 over here. So 5 and 1/3 k equals negative 3 and 5/9. In order to proceed from this point, we're going to need to get this k by itself, get rid of the 5 and 1/3. So it's 5 and 1/3 times k. So to isolate the k, we'll divide by 5 and 1/3. So we'll do that to both sides. So we keep our equation nice and balanced. Divide by 5 1/3, cancels that out. Divide by 5 and 1/3. Okay, now we've got division of two mixed numbers, one of which is negative. Again, don't get scared by it. Just go one step at a time. So k is going to be equal to what? Negative 3 and 5/9 divided by 5 and 1/3. That's what k is going to be equal to. Now, unlike adding and subtracting mixed numbers, where we can add the whole part and then add the fractional part, for multiplication and division of mixed numbers, we have to convert them into improper fractions first. So we convert them into improper fractions. 9 times 3 is 27, plus 5 is 32. So we get negative 32 over 9. Divided by 3 times 5 is 15, plus 1 is 16, divided by 16 over 3. All right, now, instead of dividing fractions, we keep change flip. So keep the negative 32 over 9. Hopefully you guys can read this. Change division to multiplication. Instead of 16 over 3, we write 3 over 16. At this point, we can simplify by canceling out some of these. So we can divide 3 over here and 9 down here, both by 3. So we get 3 divided by 3 is 1, 9 divided by 3 is 3. 16 and negative 32 can both be divided by 16. So 16 divided by 16 is 1. Negative 32 divided by 16 is negative 2. And we're left with negative 2 times 1 on top, or just negative 2. And on the bottom, 3 times 1, or just 3. K is negative 2/3. There's your answer. Again, notice it's negative because when you have one negative number divided by a positive number, then your answer will be negative. So whenever there's an odd number of negatives, remember 1, 3, 5, 7, 9, etc. When you're multiplying or dividing, that'll make your final answer negative. If there's an even number, 2, 4, 6, 8, or 0, then your answer will be positive. All right, next up, number 11, one of these lovely substitution ones where you have to keep track of your negative signs and your order of operations. So they give us this algebraic expression, a to the negative third minus a parentheses x minus a close parentheses. Now notice it's not an equation. Why? It's not equal to anything. We can't solve this unless they tell us what a and x are. Luckily for us, they do. They tell us that a is negative 2, and they tell us that x, well, they don't quite tell us what x is. They tell us that 2x plus 8 is 16, which should make it pretty straightforward for us to figure out what x is. So if 2x plus 8 is 16, then 2x is 8, and x is 4. So a is negative 2, and x is 4. Once we have those values, then we can plug them into this expression and find the value of it. So now here's where you really have to be careful to make sure that you're using parentheses when you add these things in, especially with a, because a is negative 2, and we want to make sure that that negative sign stays where it belongs. So instead of a, we'll write negative 2 in parentheses, raised to the negative third, minus negative 2, open parentheses again. We'll change them to square brackets so we can keep things straight. Instead of x, we'll write 4 minus negative 2. Okay, notice I've used a slightly absurd number of parentheses there, but that's better than using too few and getting lost. At this point, it's just following order of operations. First thing in order of operations, p, parentheses, negative 4 minus negative 2 here. Remember, those negatives are going to cancel out. Minus and negative is the same as adding a positive. 4 plus 2 is 6. All right. After parentheses comes exponents. We're taking negative 2 and raising it to the negative third power. Now, be careful. This is not negative 2 times negative 3. Those negatives do not cancel each other out. Negative exponent means that we take the number, raise it to the positive power, and put it on the bottom of a fraction. So 1 over whatever negative 2 to the third is. So 3 negative 2's multiplied together. Negative 2 times negative 2 times negative 2, which will give us negative 8. Okay, negative 2 raised to the negative 3 is 1 over negative 8, because taking 3 negative 2's and multiplying them together, it's an odd number of negatives, gives us a negative. So 1 over negative 8 minus what? Okay, now we can do, we've done parentheses, we've done exponents, now we can go to multiplication. Negative 2 times 6 is going to be negative 12. Minus negative 12. Now that we finished multiplication, there's no division. We can go on to addition and subtraction. Remember, these negatives will cancel each other out. So we end up with 1 over negative 8 plus positive 12. 12 plus 1 over negative 8. We can also write that as negative 1 over 8. We can still simplify from this point. We have 12 whole pizzas. And then we're going to take away 1/8. Someone comes along and eats 1 slice of one of our pizzas. Pizzas are convenient here because they're usually cut into 8 slices. So we still have almost 12 pizzas. We've got 11 pizzas and change. That 11th pizza has all the slices but 1, so it's got 7 of the 8 slices left. 11 and 7/8 right there. Please make sure you're careful with your parentheses and your order of operations on that one. The last one I want to go over, number 12. Number 12 here, everyone's favorite, exponents, also another great thing to go over. And they tell us two things here. They tell us, one, that they want us to simplify, and the other thing that they tell us is that they want us to make all of the exponents positive. I think it's best to wait till the end to make our exponents positive. We'll see why. It has to do with this negative power here. It's going to kind of mix things up. Okay, so first off, we need to understand what it means to take something where there's multiple parts to your term and to raise it to a power. So here we're taking all of this and we're raising it to the negative second power. Now, with our variables, that's easy. As long as we remember that when you take something that has an exponent and you raise it to another power, then we multiply those exponents together. So x squared, remember this, raising to the negative 2 has to happen to every single thing in here, not just to one of them, but to all of them. So x squared raised to the negative 2. 2 times negative 2 gives us negative 4. So x to the negative 4. Y to the negative 2 raised to the negative 2. Negative 2 times negative 2 gives us positive 4. So y to the 4th. Z, or z to the first, raised to the negative 2. 1 times negative 2 gives us z to the negative 2. Now we're not done because we still need to deal with this 2. So we're taking 2 and raising it to the negative 2 power, which means we're going to take 2, raise it to the second power, positive 2 power, and put it on the bottom. So 1 over whatever 2 squared is, or anyone? 4. We could write it that way, or I think a better way to write it actually is going to be to put it on the bottom of a fraction here. Okay, now what about the second one? Xy to the 4th. Again, we just need to make sure we apply that exponent to all the things inside there. So it's x to the 1st, raised to the 4th power, going to become x to the 4th. And then y to the 1st, raised to the 4th becomes y to the 4th. All right, now we've got these two things. Again, we can continue from here. We're not done yet. We want to simplify as much as we can, combine things as much as we can. Right now, it might not look like we can do a whole lot of combining, but if I write this over 1, okay, now we've got two fractions multiplied together. Now that's not so bad. All right, one fraction over here with this 4 on the bottom. Here, x to the 4th, y to the 4th, we put it over 1 to make our fractioning easier. And is there anything that we can cancel out here? Well, let's see. So on the bottom is pretty straightforward. 4 times 1 is just going to give us 4 on the bottom of our answer. On the top, though, notice we've got some of the variables more than once. X and x, y and y. And there's only the one z, so we won't be able to do anything to that. But those x's and y's, those we will be able to combine. X to the negative 4th times x to the 4th. Now, this is where you need to keep straight what happens when you're multiplying things with exponents as opposed to raising them to another power. When we're multiplying them together, then we're going to add the exponents. So x to the negative 4th times x to the 4th, we add those exponents. Negative 4 plus 4 gives us 0, x to the 0, or 1. So whatever else we get here, we're going to multiply by 1. Great. It's not going to change anything, so we can ignore it. What about y to the 4th times y to the 4th? We'll add the exponents. 4 plus 4 gives us 8. Y to the 8th. And then the z to the negative 2 doesn't get multiplied by anything, so that'll stay the same. Z to the negative 2. Okay, we're done, right? Maybe? No. Why? Because they also asked us, or I also asked you, to make sure that you made all of your exponents positive, but we've got z to the negative 2 here. We're not done yet. So we need to make that negative 2 into a positive 2. How are we going to do that? One of the other fun things we can do with exponents, because of the fact that a negative exponent means that you put it on the bottom of a fraction, is that we can flip around between negative and positive exponents by moving things between the bottom and the top of the fraction, or vice versa. So to get the z to the negative 2, to make that no longer be negative, we're going to take our z and remove it down to the bottom. So y to the 8th stays on top, and on the bottom of the fraction, we'll have z squared 4z squared. So your final answer should look like this, hopefully a little more neatly written, y to the 8th over 4z squared. Okay, those are the problems I wanted to go over. Hopefully my explanation was decent. tomorrow, I'll be posting some more videos with some lessons for next week. In addition, what I'm going to start asking you guys to do is, instead of doing the evens in the problem sets, to do the odds. The textbook has the answers to the odds in the back of the book. Oh my gosh, Mr. Oriani is telling us to just look at the answers in the back of the book. Yes and no. What I want you to do is I want you to be able to check your work. But what I want to see when you're submitting your homeworks is I want to see the work written out. So if you're just giving the answers, I know that the answers to all those odds are in the back of the book. So I'm not going to give you credit if you just give me the answers. But go through them, do the problems, do the work, and then check it. And if it's not correct, try to figure out where you went wrong. Or if you can't figure it out, ask me. Send me an email, send me a Jupiter Grades message, come to my office hours. All right, I think I've gone on long enough. I'll talk to you guys later. Goodbye, Duke and Altum, and don't skip leg day.